Welcome! In this series of short videos, we will look at topics for both the PowerBasic Windows and console compilers. Today we will look again at the topic of isometric graphics on a graphics control or window, but today with a view to adding animation. This was our application at the end of the last video. We had successfully displayed an isometric image across the screen, and we had amended the height of 5 of the blocks, 1 to be higher than the level and 4 to be lower. What we're going to do in today's video is we're going to substitute the colour of the 4 lower blocks to be something other than green. Additionally, we're going to animate those 4 blocks so that they rise and fall in a smooth graphics window application. So let's have a look at the code. In the previous version of this code, all the work was done within one function, the BuildGraphicMap function. What this function does is to work out the coordinate positions of each of the bitmaps, and then it positions those bitmaps on the graphics window. We're going to split this function into 2 parts. The first to initially work out where the coordinates are going to be, and the second to actually display the coordinates in the array on the screen. So firstly, we're going to make some changes at the beginning of our code. We're going to create 2 constants. These will define the size of our map, which is currently 7 by 8. We're also going to make the array which holds the coordinate positions of our bitmaps a global array. And finally, we're going to create a constant for a timer, as we're going to drive our animation by a timer on the form's callback function, the event handler. Next, we're going to replace the BuildGraphicMap function with 2 separate functions, one to populate the array coordinates and one to draw the graphics map. So firstly, we will redimension our array in here in the initialize dialog section. The dimensioning of the array is unchanged. All we've changed is where we're doing the redimensioning. Next, we want to create a new function to populate our array coordinates, to give them all their initial values. We'll call that function populateArrayCoordinates. This new function will take no parameters. At the beginning of this new function, we're going to create a number of local variables, which are identical to the local variables that existed in the previous function. Additionally, we're going to populate those variables with the starting positions on the graphics control. One of these variables is the width of the bitmaps we're going to be putting onto the screen. So as we did in the previous function, we'll need to work out just how big that bitmap actually is. So we will steal a piece of code from that other function. We'll define the bitmap's location in the graphics folder, and then we will open the file in binary mode and pull back the width and the height of the graphic. Now we will take the code that was in the previous function, which populates the array. This array is now global, therefore we don't have to dimension it within this function. The only difference within this nested for next loop is we're using the constant for the maximum y and maximum x coordinates. The rest of the code is exactly the same as it was before. The next thing we did was to adjust the heights of some of the cubes. We adjusted the height of 4 cubes in the centre of the grid and raised the height of 1 cube at locations 3 by 3. So we'll slot that code in as well. So that should complete this new function. So having populated the array coordinates, which are our initial values, we now want to draw the graphics map itself. So we will comment out this old function we used in the last video, and we'll make a call to our new function. This, like the previous function, will take 2 parameters, the first being the handle of the dialog and the second the handle of the graphics control. The purpose in splitting this original function into 2 is that we have a standalone function which can draw the graphics map based on the coordinates that currently exist within the array. This means we can call this drawGraphicsMap function periodically, and it will display the bitmaps based on the values held within the global array. So as we did before, we're going to set up our bitmaps. and we're going to set up a new bitmap to hold the new graphic. We have a graphic for the green cube. We now need one for a different colour. So I have created a new graphic. My initial plan was to use a red cube, but we've ended up with something that's more brown than red. But we'll keep going using that. This new bitmap is exactly the same size and orientation as the original green cube. So we now have a new variable to store this brown bitmap. As the mask for this bitmap is exactly the same, we don't need a separate mask. But we do need a handle for the bitmap itself. So we can populate the brown bitmap variable with the path and name of the file we're going to be pulling in this case mapcube3_red.bmp. And as we did in the other function, we need to determine the size of our bitmaps and the existing code to load the bitmaps into memory. And as our brown bitmap is a separate file, we need to load that in as well. In the previous function, we then set the values up in the array. Now this has already been done in the previous function. So all we need to do now is to use a for next loop, nested for the columns and rows, to display the masks and the bitmaps on the graphics control. So our nested for next loop is starting with columns first and then doing rows. And we want to use the graphics copy command, as we did in the previous function, to pull the mask bitmap in and position it first on the screen. Next we'll use the graphics copy command again to do a merge source for our actual bitmap. But as we want some of the cubes on screen to be a different colour, we can first determine which column and which row we're actually doing. So as we wish to place a different colour bitmap in the centre of the screen, we're testing the value of long row and long column. This is then used to determine which bitmap to use, the brown bitmap or the ordinary green one. The code other than that is absolutely identical. And following that test, we do a next for the row and the column, ending up the function with the graphic bitmap end to free up the memory used by our bitmaps. So if we try running our application now to see how it looks. And there we have on screen our updated bitmap. It's doing exactly what the previous program did, the only difference being is that the 4 blocks at the centre of the map are actually a different colour. Now that we've achieved that, what we want to do next is to use our timer to animate just those 4 blocks by amending their locations in the global array. So if we have a look at the callback function itself, and we're going to make some changes in here to initialize a timer. So after we've drawn our initial set of graphics, we're going to set our timer going. And at the moment, I'm going to set the timer to trigger every 200 milliseconds. And we need to add a timer event to pick up the fact that the timer has actually triggered. And we're testing the value of wparam to ensure that it's the timer we want. This allows you to set up multiple timers within your application. Because we haven't determined yet how long it's going to take the application to draw the graphics on the screen, we want to ensure that the timer event only triggers when it's not already running. So we're going to set up a static variable to keep track of the fact that the recalculation of the positions and the redrawing the graphics map is not actually running at the moment. So we will create this static variable at the beginning of our function. The advantage in using a static variable is that the function will remember the value of that variable each time it is called. So if it's called initially and the value is set, then when the function is called again, it will remember the previous value of that variable. So in our timer event, the first thing we will do is to test to see if long running is true or false. If it is true, then we will exit the function. Next, we're going to set the value of long running to be equal to true. And then we're going to attempt to recalculate the positions to be stored within the global array. We'll create that new function in a moment. But on the assumption that this function has actually run, our next task would be to redraw the graphics map. As we've already created a draw graphics map function, all we need to do is to clear the graphics on the graphics control, call that function, and then give the graphic redraw command to redraw the screen so the user can see the update. And then we can mark long running to be equal to false. So let's create the new recalculate positions function. What I want to do within this function is to recalculate the position of just the 4 blocks at the centre of the grid. Initially to move downwards, then stop, and then move back up again. And once they've moved up far enough, they will stop and the cycle will repeat. So we're going to create a couple of static variables in here. One to count the number of frames we have displayed to the user, and one to count the vertical offset. This will either be a -1 or a +1, as we're going to move each of these blocks 1 pixel at a time. So there are our 2 static variables. The vertical offset, if it's initially 0, we're going to set it to be equal to 1. And our next task will be to increment the frame count. So this will start off as 0, and then the first time this function is called, it will increment to the value of 1. And this will go up by 1 number each time this function is called. So by the use of a simple select case statement, we're going to put 2 rules in place. One for when the value of the frame count gets to 50, and one when it gets to 200. Next we want to change the value of the coordinate held for these 4 blocks. So a simple for next loop will step through each element of our array, and we're setting the third dimension, number 2, to be the new value by adding on our vertical offset. So let's try running the application now. And there are our center blocks descending downwards. Once they've reached their limit, they will start upwards again. The animation at the moment is a little jerky. Let's see if we can improve on that. At the moment, our timer is triggering every 200 milliseconds. If we drop that down to 50 milliseconds, that should mean we're getting 20 frames a second. So let's try that code now. And our graphic animation is looking a lot smoother. The cubes are going down, then coming back up again, and once they've reached their upper limit, they should start to descend again. And the cycle will repeat. So what we've achieved today is we've used a second colour for our cubes. We've also managed to smoothly animate the graphics on screen using our graphics control. Hopefully you'll find this code useful in your applications, but that's it for today. Thank you for watching.